All right, guys, here we go. Pre-calculus section 9-1, homework page 613. We're going to talk about an introduction to sequences and series. Okay, so ideally we want to use sequence notations to write terms of a sequence and find the sum and factorial. So a couple things you need to understand about sequences. Okay, sequences is a set of patterned numbers. Okay, terms. These are called terms. They're represented by a sub 1, a sub 2, a sub 3, a sub 4, and on and on and on. All right. To write terms of a sequence, you look at the equation, the sequence notation, and you plug in 1, 2, 3, 4, 5, all the way as many terms as you want. Okay. So ideally, you want, given terms of a sequence, you want to find the pattern and write the equation for it. Couple of things to keep in mind here is called factorial. It's n factorial with exclamation mark. N factorial is going to be n times n minus 1, n minus 2, n minus 3, all the way down to 1. Okay, so we'll do some examples on that. Fibonacci. So Fibonacci numbers is the pattern of numbers. Okay, this pattern is called the Fibonacci. So it starts as 1, 1, 2, 3, 5, 8, 13, and on and on and on. Okay, summation notation. Okay, so on a sigma notation, this kind of like a big E or a sideways M. It says I start equals 1 through n of AI. And so you have to figure out term number 1. Okay, it says start here and ends at n. So term 1, term 2, term 3, term 4, on. And you stop when you put in term n. Okay, you want to find all the terms and then add them together. Okay, so that's something we are going to go over. Something that's important is called infinite sum. And this is when you have a pattern of numbers where it's a geometric series, meaning you're multiplying to go from one term to the next. And this is a simple formula here, a1 over 1 minus r. But the catch is your pattern numbers, they have to be multiplying by an r, absolute value r, which is less than 1. Okay, so when the number is shrinking, you can actually find the total for all the numbers in existence for that pattern. Okay, so we'll do some examples. All right, so let's say, for example, a couple of things you're gonna have to do in your work. They're gonna ask you to write, okay, the first 5 terms of, okay, an equals 3 minus, or 5 minus 3n. So excuse me for that. 5 minus 3n. Okay, so they're gonna ask you to find the first 5 numbers. So a sub 1, you plug in 1 into here. This is gonna be 5 minus 3 times 1. So a sub 1 is gonna be 2. A sub 2 is gonna be 5 minus 3 times 2. See, whatever this number is, you're gonna put it there. So a2 is 5 minus 6, so negative 1. A sub 3 is 5 minus 3 times 3. So a3 is 5 minus 9, negative 4. Okay, so we want to find the first 5 terms. A4 will be 5 minus 3 times 4. Looking at 5 minus 12, negative 7. And fifth term, they want 5 terms, so we're going to do that again. 5 minus 3 times 5. 5 minus 15, oops. So you get negative 10. Okay, so your first 5 numbers are 2, negative 1, negative 4, negative 7, and negative 10. They only wanted the first 5 terms, so that's it. Okay, so next example, let's say you have an equals 5 to the n. Okay, first 5 terms. You want first 5 terms, so a1 is 5 to the 1, that's 5. a2 is 5 to the second, That's 25. A3 is 5 to the third. We're just plugging in n there. We're plugging in this value up as a power. So 125. A4 is 5 to the fourth, 625. And then a fifth is 5 to the fifth, 3,125. So my first 5 terms are 5, 25, 125, 625, and 3,125. So when they want terms, that's all you got to do. Okay. Now, what they're going to have you do next, okay, this next set of prompts is they want you to find the equation, okay? Find pattern, find the pattern, or, equation, okay, of the sequence. Okay, so for example, let's say you have 2 over 5, 2 over 25, 2 over 125, 2 over 625. So what's the pattern here? What's going on? Can you guess what's next? Okay, my next term, what I notice is that the 2 staying the same, still going to be 2, but look at the denominator. It's going to be 5, 25, 125, 625. So what you notice is multiplying by 5, multiply by 5, multiply by 5. So my next number I'm going to guess is 3,125. So AN, the general pattern, that's what AN represents, general pattern, is going to be 2 over 5 to the n power. Okay, so that's how I found that. Okay, so depending on the pattern, you're going to have to be able to do that. Okay, so next example, let's say we have 3, 5, 7, 9, dot, dot. Okay, this one's pretty simple. Okay, of course, your next number is going to be 11, 13, and 15, on and on. Okay, so you have to write the equation for it. So what you notice is that these are all odd numbers, right? So this one is going up by 2. Is going adding by 2, adding by 2, adding by 2. So AN, because you're adding by 2, is going to be 2 times n. Okay, so now, see, when I plug in a 1, I should have 3, but this guy is a 2. So what I do is I add 1. Now this should check. When I put a 1 into this equation, I get 3. If I put in a 2, I get 5. So this will work. Okay, so if you're multiplying, if you're adding by the same value each time, then it's that value times n, versus my earlier example, I'm multiplying by 5 each time. So it's going to be that number to the power. Okay, so let's see about 4, 8, 12, 16, dot, dot, dot. Okay, so now, what do we notice is going on here, right? We're adding 4, we're adding 4, we're adding 4. So my next number I would guess is 20, 24, 28, dot, dot, dot. Since I'm adding 4, then the pattern is going to be 4 times n. All right, now let's check and see if it fits. If it fits, perfect. If it doesn't, then I have to adjust by adding or subtracting here. Put in 1, I get 4. Put in 2, I get 8. Put in 3, I get 12. So this is going to be fitting perfectly. Okay, there you go. Okay, so here's an example that might be kind of difficult, but you got to learn to see if you can find the pattern, okay? 66, 127, and 218, dot, dot, dot. Okay, so what do we notice here? Okay, take a look at this here. 3, 10, 29, 66, 127, 216. Okay, so what I notice, what I see here, that this is sort of like 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, 6 cubed. But you see, each time I'm doing that, I'm off. I'm off by 2, right? If you notice, it's 1 cubed plus 2. That'll give me 3. 2 cubed plus 2, I get 10. 3 cubed plus 2. 4 cubed plus 2. 5 cubed plus 2. See that? So my equation is going to be n cubed plus 2. And that should fit. That's how I do that. All right. Okay. Next thing we're going to do is kind of evaluate sigmas. Evaluating sigmas. Evaluating sigmas. And this is pretty simple. You're trying to find the sum. So for example, they're going to give you something like this. Sigma. This is called sigma. I equals 1. You start here. This is your starting point. Start with this number. And you end when you reach this number, okay? So here's your equation. I squared plus 3. So it's pretty simple. You start here, you plug it in. So when you write this out, it's 1 squared plus 3. Okay. Then you use 2. 2 squared plus 3. Then you use the next number. 3 squared plus 3. 4 squared plus 3. 5 squared plus 3. 6 squared plus 3. And 7 squared plus 3. I'm going to stop here. I'm going to stop here because this says go up to 7. Okay. So now when I evaluate these, 1 squared plus 3 is 4. 2 squared plus 3 is 7. 3 squared plus 3 is going to be 12. And then 19. 4 squared plus 3 is 19. 5 squared plus 3 is 28. 39. And 7 squared plus 3 is 52. Now my job is sigma is to make sure I add all of these together. Okay, I have to manually add these or use a calculator, doesn't matter. Okay, 11, 19 is 30, 42. 42 and 28 is going to be 70. 70, 109, and 161 is my grand total of the sigma. Okay, so that's it. You write out starting at this and you go up to that number. Okay, so again, 11, I get 30, 70, and 161 is perfect. Okay, so let's do some more sigmas. Okay, so for example, evaluate the sigma of I equals 1 through 5. Now in general, they normally give you a 1 here to start out with, but it's not a must. Sometimes they might get funky a little bit and they start with like a 3 or whatever. Okay, no big deal. But whatever you want, you have here, you start with that guy. 9 times 1 plus 8. 9 times 2 plus 8. 9 times 3 plus 8. 9 times 4 plus 8. Last one, 9 times 5 plus 8. Again, I'm going to stop here at 5 because this says stop at 5. So my first number is going to be 17, 26, 35. Let's see here, 44 and 53. Okay. So now I just gotta manually add these. Okay, so this is 70. This is also 70. And so 140, 170 equals 175. Okay, so that's it. That's it. That's how you do that. Okay, so earlier, remember I told you, you don't necessarily have to start with 1. So let's say they start with 4, okay? 4 to 7 of 8i plus 5. Okay, see the index, this is called an index. It generally starts at 1, but it doesn't have to start at 1. Okay, no big deal. So 8 start here times 4 plus 5. Then you're going to do 8 times 5 plus 5. 8 times 6 plus 5. 8 times 7 plus 5. I stop at this number. I start down here at the index 4. I stop at 7. Okay, so I get here 37, 45, 53, and let's see here, 61. Now I'm just gonna add all these together. Okay, so 98, 98, looking at grand total 196. That's it. Okay, so try that on your own and see how you do. Okay, have a good time.